Okay, welcome back everyone. In this video, we're going to take a little bit of a detour and we're going to be talking about conservative and non-conservative forces. And you might think that when we say conservative forces, we're talking about, a lot of people who listen to Rush Limbaugh, but no, this has to do with work and energy. I couldn't resist. This is a pretty important concept to at least hear about for right now. And we may not use it very much, but or at least we may not realize that we're using it, but as a matter of fact, it's very important. So the idea with a conservative force is that if you have a conservative force, the total work which is done on a closed path is equal to zero. Now, when we say a closed path, what we're really talking about is that the displacement is equal to zero, or delta D is equal to zero. And so we've talked about how we do work so far, and you've seen some videos on how work is calculated. But if we have a situation where an object moves around because of a force and gets back to its original position, and the total work done is zero, that's the definition of a conservative force. For example, let's say that I have a 1 kilogram object and I move it upwards, or it moves upwards 1 meter because of whatever, it's just moving upwards. Okay, what work does gravity do as it's moving upwards? Well, the work of gravity as it moves upwards is equal to the force times the displacement times the cosine of the angle between them. And if we think about this, the force of gravity is going to be mass times gravity. Let's just call that 10 newtons. And so the work that gravity does in this case going up is equal to the force of gravity 10 newtons times 1 meter. But because those force vectors are in opposite directions, there's a 180-degree angle, and the cosine of that is -1. So this is another way of saying that the work done by gravity as it goes up is -10 joules. Okay, and that's something that we have practiced in the past. Well, what happens if that same object moves back down 1 meter because of gravity? Okay, well again, we have the force of gravity pointing down as 10 newtons, but this time when we calculate the work done, the work that gravity does going down is still equal to FD cosine theta, but the angle between the force and the displacement is 0 degrees because they're going the same direction. So the work that gravity does going down is basically 10 newtons times 1 meter times 1, and that work done by gravity is positive 10 joules. So that makes sense for each half of this motion, going up and coming back down. Now, if something goes up and then it comes back down to the same height, then basically the displacement is 0. And if you add the work going up that gravity does plus the work that gravity does as it goes down, well, the total amount of work is the work going up plus the work going down, so we can see that that's 0. So this is another way of saying that this is a closed path, right? Because the object is ending right where it began, same position, displacement is 0, and the total work done is 0. So gravity is an example of a conservative force. And we actually need to make use of that for many of our laws. For conservation of energy, for example, which is coming up, or which you probably already learned about actually. Okay, and Now quickly, let's talk about a non-conservative force. Well, it makes sense that a non-conservative force has a total amount of work which is unequal to zero on a closed path. I can't write closed today for some reason. That's better. Okay, so an example is, imagine you have a tabletop. Okay, there's my table, whatever. Okay, and you have this book or block or whatever, and you drag it around and you go in some weird pattern. Okay, now if you added up the total amount of work done by friction on the path, it's not going to be zero, because at any point in the path the object's going to be moving one way, but friction will be opposing, and that's always going to be true. Okay, so the distance and the force of friction, the distance and the force of friction, distance and the force of friction. So the work is going to be some negative value. We don't know what, but it's something negative. But it's definitely not equal to zero. So friction is a good example of a non-conservative force. And this is pretty much all that I wanted you to see about conservative and non-conservative forces. It'll become much more important a bit later on.